What if Earth's largest unexplored place is not hidden under ice, buried in desert, or sealed in a jungle, but moving in plain sight? It covers about 71% of the planet, touches nearly every continent, shapes weather, carries heat, feeds vast ecosystems, preserves wrecks, and swallows mountains. And still, we know only part of it. Only about 27% of the ocean floor has been mapped in high detail, which means large areas of our own seabed remain less familiar than parts of Mars. The mystery does not begin in the deepest trench. It begins at the surface, where the ocean seems almost understandable. People swim there, sail there, fish there, and look down through bright water at sand, coral, and color. For a few meters, the sea feels human-sized. You can float on it. You can see sunlight move through it. Near shore, you can touch the bottom and feel like you know where you are. But that bright layer is only the lid. Beneath it, Earth opens into a vertical world more than 11 kilometers deep at its lowest known point. Most of that distance is not warm beach water. It is darkness, cold, pressure, falling debris, ancient wreckage, strange migrations, and ecosystems so remote that reaching them can be harder than crossing space. To understand the ocean, the most important direction is not across, it is down. Even the surface is more complicated than it looks. In 1992, a cargo ship in the North Pacific lost nearly 30 plastic bath toys into the sea. They were ordinary floating objects, but once they entered the water, they became accidental trackers. Some later washed up across the Pacific, others drifted toward eastern Canada. A few eventually reached Scotland. Their strange journey revealed that the ocean surface is not a simple moving sheet. It is a global system of currents, loops, delays, crossings, and hidden routes. A small object dropped in one part of the Pacific could travel for years and expose invisible highways connecting distant coasts. So even where sunlight is strong and ships are common, the ocean is already more complex than it appears. Now descend. At around 30 meters, you are still in shallow water by ocean standards, but human history is already gathering around you. Ships move near coasts, reefs, ports, storm tracks, trade routes, and battlefields. That is why many of the world's estimated 3 million shipwrecks lie in relatively accessible depths. One famous example is the SS Thistlegorm, a British supply ship sunk in the Red Sea during the Second World War. When divers later explored it, the cargo was still there. Trucks, motorcycles, weapons, railway parts, even a locomotive. A ship built for war had become a reef of steel, coral, and fish. Divers can move through a suspended fragment of the 1940s, while the sea slowly turns machinery into habitat. But compared with the true depth of the ocean, this wreck is almost at the surface. If the deepest ocean were a skyscraper, the Thistlegorm would be near the entrance. Keep going. Around 100 meters, sunlight still reaches the water, though it begins to weaken. This is part of the sunlit zone, where photosynthesis is possible and life can be dense, colorful, and fast-moving. Here, the story expands from one wreck to one of the largest living systems on Earth. The Great Barrier Reef stretches about 300 kilometers along Australia's coast and covers nearly 350 square kilometers. That is roughly the scale of a country. It is not one reef, but a vast region of coral, fish, sharks, eels, turtles, dugongs, and countless smaller organisms that depend on the structure. It begins in shallow water, but parts of it descend toward dimmer blue, and it carries a warning. Even in the layer where life looks abundant, warming seas and changing conditions can damage entire worlds. A reef can take thousands of years to build, and only a short time to push toward collapse. The ocean is not just deep, it is vulnerable. It also keeps records. Off Italy, around 160 meters down, robotic submersibles have found Roman-era cargo ships from the 1st century. They carried hundreds of terracotta amphorae, likely filled with oil and wine. At that depth, people cannot simply swim down and search through the past. Machines have to go first. The result is a strange kind of preservation. Trade routes disappear, empires fall, ports change names, but clay jars can remain in the dark for almost 2 years, holding the shape of a voyage that never arrived. The deeper you go, the more the ocean becomes both a museum and a wall. At about 200 meters, daylight begins to fail. This is the entrance to the twilight zone. Above you, the surface still exists, but it no longer feels close. Light fades from blue into gray, then toward black. Animals can no longer rely on bright reefs or clear vision, so some of them create light of their own. Anglerfish live in this dim world with glowing lures that hang in front of their mouths. In a place where food is scarce and sight is limited, light becomes a weapon. A small glow can mean food, or it can mean a mouth waiting in the dark. The twilight zone is not empty. It may be one of the most crowded places on the planet. Estimates suggest that about 90% of the world's fish live in this near-dark layer. Among them are bristlemouth fish, tiny deep-sea animals that may exist in numbers so vast they are hard to imagine. Hundreds of billions, possibly far more, maybe even approaching a quadrillion. That is not a number we usually attach to vertebrates. It sounds more like a count for stars or grains of sand. And yet one of the most common backboned animals on Earth may be a small fish most people will never see. As you continue downward, two forces begin to control everything. Temperature drops, pressure rises. Your body is built for the surface, but the animals here are shaped by darkness and compression. Around 500 meters, the giant squid enters the story. For centuries, sailors described huge shapes in the deep, long arms, pale bodies, and creatures large enough to become legends. The giant squid is real, and it helps explain why myths formed. Imagine seeing only part of it. A tentacle near the surface, a scar on a whale, a pale shape rising from black water and then vanishing. The deep ocean does not have to invent monsters. It only has to reveal real animals out of context. Then, in the 1940s, scientists found something stranger than a creature. Sonar began detecting what looked like a false seafloor. Ships sent sound downward, and the echo returned too soon, as if a solid bottom were suspended in the water. But the real seabed had not moved. The false bottom was alive. It was a dense layer of fish, squid, jellyfish, and other organisms, thick enough to confuse sonar. This became known as the deep scattering layer, and it was not still. Every day, countless animals descend in the morning to avoid predators. Every night, they rise toward plankton-rich waters above to feed. Some travel nearly a kilometer vertically. This is one of the largest daily migrations on Earth, and most of it happens beyond human sight. Not across land, not along a river, straight up and down through the dark. The middle ocean is not empty space between the surface and the bottom. It moves like a hidden living tide. At about 10 meters, you enter the midnight zone. Here, sunlight is gone. Not dim, not fading, gone. If a submersible switches off its lights, the water outside becomes complete blackness, broken only by living flashes and drifting particles. When the lights return, something appears in front of the window like snow. It is not ice. It is marine snow. Tiny fragments of dead plankton, waste, mucus, scales, and organic material falling from the layers above. In the deep sea, this slow rain is food. An animal living far below sunlight may depend on debris from creatures that lived and died hundreds or thousands of meters overhead. The surface feeds the darkness, grain by grain. Sperm whales can dive into this black water, hunting squid at depths that would destroy unprotected human bodies. But even they do not naturally reach one of the most famous human landmarks in the deep ocean. At about 800 meters in the North Atlantic lies the wreck of the Titanic. It sank in 1912. It was not found until 1985. For more than 7 decades, one of the most famous ships in history sat beyond ordinary reach, under cold and pressure that turned depth into protection. Its depth is roughly comparable to the height of Mount Fuji. Now imagine that mountain inverted beneath the ocean's surface. That is the vertical distance separating the Titanic from air. At that depth, a mistake is not a setback. It is a direct confrontation with pressure, darkness, cold, and isolation that the human body cannot survive. The wreck is still recognizable, but it is decaying. Metal breaks down, structures weaken, objects lie scattered across the seabed, tied to passengers and crew whose lives ended far above where the ship now rests. The Titanic feels deep because, for human history, it is deep. But the ocean continues. Below about 40 meters begins the abyss. The word sounds like emptiness, but that is misleading. The abyss contains vast plains, some of the largest habitats on Earth. They are not crowded like reefs. Food is scarce, light is absent, pressure is extreme. But life is still there. Octopuses move through the darkness. Sea cucumbers cross the sediment. Glass sponges rise from the sea floor in delicate shapes built from silica. Some of these sponges may live for thousands of years, possibly longer. A human civilization can rise, vanish, and become archaeology, while a deep-sea sponge remains alive in cold darkness. Time behaves differently here because energy is rare. Marine snow falls constantly but thinly. Then, occasionally, the abyss receives a feast. A whale dies near the surface or in the open ocean, sinks through the water column, and lands on the seafloor. This is called a whale fall. For deep-sea animals, it can become the center of an entire ecosystem. First, scavengers arrive. Sharks, hagfish, crabs, and other animals strip the soft tissue. Then, worms, mollusks, bacteria, and smaller organisms use what remains. The bones themselves become habitat and fuel. A single whale can support life for decades, sometimes up to 50 years. One death in the upper ocean becomes half a century of opportunity on the seafloor. That is the hidden economy of the deep. Energy is too valuable to waste quickly. Life gathers around it, transforms it, and waits for the next impossible gift to fall from above. But the abyss also has a source of energy that does not come from sunlight, falling debris, or dead whales. It comes from Earth itself. Along tectonic rift zones, hydrothermal vents release hot, chemical-rich fluids from volcanic systems beneath the seafloor. For a long time, it was natural to imagine sunlight as the base of life. Plants use it, plankton use it, food chains rise from it. But hydrothermal vents revealed ecosystems powered by chemistry. Bacteria and other organisms use sulfur compounds and mineral-rich fluids in total darkness. Around them, entire communities form without sunlight. That discovery changed the question from how life survives down there to where else life might survive without sunlight at all. Scientists look at these vent systems and think about worlds like Europa, one of Jupiter's moons. If an ocean exists beneath its ice, and if chemical energy is available there, then Earth's deep sea may be a clue to life beyond Earth. The ocean floor is not just a remote landscape. It is a laboratory for the limits of biology. It proves that life can persist where sunlight never arrives, where pressure is immense, and where geology and ecology become almost the same story. Then, the descent becomes narrower. The abyss is vast, but the deepest parts of the ocean are trenches. At around 60 meters, the Hadal Zone begins. This is the realm of the deepest trenches, named after the underworld in Greek myth. But the reality is more extreme than the name. Total darkness, Near freezing water, isolation, pressure so intense that ordinary materials can deform, fail, or implode. At these depths, every visit from the surface requires engineering, planning, patience, and the knowledge that rescue would be nearly impossible. Scientists have found fish, such as snailfish, as deep as about 8 kilometers. That is already staggering, but below that, pressure may become too severe for animals with bones. The ocean is no longer only cold and dark. It is pressing on life from every direction. At 10,0 meters, you're deeper than the distance a person can normally see to the horizon from land. That comparison is hard to feel because we usually think sideways. So turn the horizon downward. Take the distance from where you stand to the farthest visible line on a flat landscape, convert it into depth, and place an ocean above it. And in the Mariana Trench, the seafloor still drops farther. The deepest known point is Challenger Deep. It reaches about 1134 meters, or 36,201 feet. Mount Everest could be placed inside this trench, and its summit would still not break the surface. There would still be water above it. At the bottom, the pressure is more than 8 tons per square inch. That number is almost too large to imagine. Every exposed surface is being squeezed by an invisible weight powerful enough to crush unprotected equipment instantly. The water is near freezing. The darkness is complete. The distance from the surface is so great that descending there feels less like diving and more like leaving the familiar version of Earth behind. And yet, this is still our planet. More people have walked on the moon than have reached the absolute bottom of the ocean. In 1960, 2 men descended to Challenger Deep in the bathyscaphe Trieste. Decades later, James Cameron made a solo journey to the same region. These expeditions were not just records. They were reminders of how hostile Earth can be to the species that dominates its surface. We build cities, launch spacecraft, map other worlds, and cross continents in hours. But the lowest point of our own ocean remains a place only a tiny number of humans have personally seen. And seeing it is not the same as knowing it. The ocean floor is vast. Much of it remains unmapped in detail. Many ecosystems are difficult to observe without changing them. Its currents connect distant continents. Its wrecks preserve war, trade, disaster, and ambition. Its reefs build living architecture at continental scale. Its twilight layer hides one of the largest migrations on Earth. Its midnight zone is fed by a slow snowfall from the living world above. Its abyss can turn a dead whale into decades of habitat. Its vents show that sunlight is not the only foundation for life. And its trenches sink into pressure so severe that biology itself meets a boundary. The real mystery of the ocean is not simply that it is large. We already know it dominates the map. The mystery is that its size hides vertically. From the beach, the sea looks like a surface. From a ship, it looks like distance. From space, it looks like blue. But beneath that blue is a stack of worlds, each with different rules. At the top, currents carry objects across hemispheres, and people swim through sunlight. A little lower, ships become reefs, and ancient cargo waits in silence. Lower still, living lights blink in the twilight, while billions of fish rise and fall through darkness. Then comes midnight, where marine snow carries the remains of the sunlit world into black water. Then the abyss, where food is rare, time slows, and a single fallen whale can feed a community for decades. Then the vents, where Earth's heat powers life and hints at alien oceans. And finally, the trenches, where the planet narrows into cold pressure deeper than the tallest mountain is high. The strangest part is that none of this begins far away. It begins at the shoreline. A person can stand with waves around their ankles, looking at the same ocean that drops to Challenger Deep. There is no wall between the beach and the abyss, only depth. Layer after layer, The familiar world disappears. Light fades, pressure rises, history sinks, life changes shape, and Earth reveals that its largest frontier was never beyond the sky. It was below the surface all along. So the next time the ocean looks flat, remember what is underneath it. A drifting toy root that crossed oceans, a warship covered in coral, a reef system the size of a country, Roman jars resting in deep water, a false sea floor made of migrating life, a famous wreck lying as deep as a mountain is tall, a whale skeleton feeding an ecosystem for decades, volcanic vents that may resemble oceans on distant worlds, and one trench so deep that Everest would disappear inside it. The ocean is not just water around the land. It is the largest hidden landscape on Earth. And if only about a quarter of its floor has been mapped in detail, then the final question is not what we have found down there. It is how much of our own planet is still waiting below the blue.